this could be maybe a high-rise, maybe it's for flowers, but I think what is interesting is, how the elements connect together. And I think I'm showing this picture because I think it's not just about architecture, it's not just about fashion design, it's not just about objects, but I think it's also our social behavior, where we are starting to think much more in a network-based basis of how we can connect with other people throughout the world. So I think it is important to say that this is not just architecture, but it intervenes actually social behavior and other fields of design.
After giving you just a very broad context of what digital design and digital fabrication, constitutes nowadays, we would like to get more focused, and we are very much interested to see how we can categorize and systematically analyze these new methods of digital design, which do not exist for a long time. They evolved during the last 10, 15 years, and we would like to share with you some of the main themes or main categories where we think that digital design and digital fabrication moves to. Well, digital fabrication is, first of all, it's a kind of new technique really allowing architects to become more powerful in the process of designing, because through digital fabrication you can create a direct connection between what you have on the screen virtually in Rhino, Grasshopper, in a virtual world as a 3D model, and then directly link it with the production facilities. And sometimes just eliminating the traditional way of how architects work, because you do not have to draw intermediary plans, sections and so on, but sometimes what you have on the screen you send to the 3D printer and it's literally there. It also introduces a new materiality, because it makes new forms possible which have not been possible before, by using laser cutters, CNC machines, and so on. It might make this architectural design process much more efficient, because you as an architect would have more time to focus on the design process itself without, let's say, I don't want to say losing time, but without being involved in many of these intermediary steps like sections, plans, detailed drawings. Everything becomes combined into one model, which then gets built by robots, basically. One other important aspect is the technology upgrade. Many of these techniques we're showing you right now have been used for 15, 20 years, almost 25 years in other industries like plane building, car manufacturing. They all used industrial robots, and these robots now become cost competitive, become cheap enough, and become spread enough to be able to use them also in the day-to-day architectural production. So here is a point where we can really learn and integrate knowledge from other disciplines. And we do really think this is one of the most important aspects of digital design and production.
And also, as mentioned before, I think it is very important to understand conceptually what digital design implies. And I think one of the most important aspects of it is that what we do is we increase the amount of elements that we bring into a system. And this could be a form of organization. And this was an incident in the UK where a ship very close to the coast sank, wrecked, and it was loaded with wood. And all the wood was swept on the beach. And I think there is a certain beauty in the aggregation of the elements that one can see here. But obviously, nobody would say that there is a form of organization or conceptual approach of how these pieces come together, while on the other hand, this project is also just pieces of wood that have been more or less randomly put together. But again, I think as an architect, this is more of an older approach of having an ideological approach of a finished product, and the only parameter that drives the project is, let's say, the sketch of the architect, the imagination of the architect, but not so much how the individual pieces come in place. So that means, one of these pieces could be anywhere else in the system, where, this is another picture just, where in this project here, and this is Frank Gehry's concert hall, the steel structure in LA, it looks very similar, but the form of organization is very precise. Every element has a number and is determined in a very specific place. And I think that digital fabrication, parametric design, however you approach it, is this kind of organization that it is looking for. Every piece has its specific length, number, and position in the overall organization. And you can see the amount of elements that one uses here to establish the structural depth for the concert hall. And this kind of organization would most probably not be possible without the use of different ways of production, but also different and new kinds of software. Also, another project, obviously, that we all know from Herzog de Meuron in Beijing. And I think on an academic level, this is the kind of approach that we take. We use new software, and we can also actually almost see that the layout, the visual layout and organization of the software becomes almost the organizational diagram, the narrative story from the very left side, which is the start of the project, to the right side, which is almost the output of the project. And everything in between is like a story, and you can, most of you guys know it, you can change it at any given point. And this is a project in Mexico, and I think that it's a suburban project, it's repetitive housing, and I think that this is what, on let's say almost an organizational and an aesthetic level, we're trying to abolish today, to come to these kinds of organizational forms, which on the first hand might look fancy and you might like it or not, but the ability and the difference between this organization and this organization is that these kind of organizations have the capability to adapt. They could adapt to a structural performance, they could adapt to environmental performance, and they have the ability to, almost like an organic form of organization, to incorporate different kind of intelligences into their system. This is again just a student project with repetitive elements. But if you compare this project, which has repetitive elements, and this project, you see the clear difference what you can achieve.
Yeah, and these are some more examples of student work which has been done at the ATH in Zurich with Gramazio Köhler. And again, here the idea being that differentiation and gradation creates a new kind of organization. And these patterns, again, how fancy they might be, have some inherent logic in them, and this logic can be used for structural, for functional, for aesthetic, for orientational reasons. What we think is really interesting is the point where these ideas become real space, where they do not stay at the level of ornament, but where digital design and fabrication is achieved at a scale where it becomes special. Not special, but spatial, okay, where it creates space. And of course, as we mentioned, industrial robots make a difference here, because they allow mass customization. A robot doesn't care if it cuts, if it cuts a circle, a square, whatever shape, if the length of the cut is the same. But it can be, as opposed to traditional construction techniques where standardization was important, for a robot, for a laser cutter, it's not important at all. So as soon as you have the same length or the same amount of material that you cut, you can do whatever, you can bring in whatever gradation differentiation that you want to have. Again, the idea how digital, how these properties can really change the way how we approach construction, approach facades, approach structures. Also the idea that these digital fabrication tools do not affect only architecture, but our general cultural context, this being digitally fabricated pieces, which become important because they improve public space, because they are used in different ways, because they can float, they can be used as furniture. So it is this level of engagement with the context that we think is important, and we think that digital fabrication should really go beyond the virtual world on the staying in Grasshopper or on the screen. And this is another project where digital design and digital fabrication plays a huge role. This is the South Korea golf resort by Shigeru Ban, where the CNC milled elements, laminated wood beams, basically, are created and are arranged in multiple lines or axes in order to create special effects.
I think it is also important to mention that although this project has the scale of a building, it's a huge project, there is not much difference between the conceptual approach that we tried to go in the workshop in the last couple of days. So this is the overall organization, and you can see that it is broken down into components. The same way we started within our workshop to define and build up a component, this project is also built on repetition. So this is a field of components. You can see the kind of like grid lines. This would be the singular component. And then this component is basically subdivided into differentiated parts. These would be all wood beams with different lengths, different curvatures, and also very important, already out of the computer, the intersection points between the wood beams. And you can see here how, again, digital fabrication tools, a cutter, is actually cutting out the intersection points within these beams. You can see here the finished beams with the cutouts of all the intersection points. And you can see how the finished component, not by hand, but by crane, is being put in place to basically establish the overall structure. So you can see how there is a very inherent similarity between, conceptually speaking, between a student workshop and an actually really interesting build project. Obviously, the level of complexity, the level of precision and fabrication is different in the two processes. But the conceptual thinking on an academic level and in a professional level is very much similar. And obviously, we would also like to mention that I think both of us we really admire a company that is called Design to Production, which is not an architectural company. It's a consultancy company who works together with architects, and most of the work that we show here is obviously their work. This here is it's a curved piece of wall, but the wish of the architect was that they want to make this piece of wall out of concrete, and as we know, you need to build shuttering for concrete in order to pour the concrete inside. So usually you have straight walls and you have elements you put on and you take off, but the architect wanted to have this double curved, so it was kind of a really big challenge how to break down a double curved surface into flat panels. And you can see that again this company really engaged themselves with turning a double curved surface, breaking it down into different lengths of the elements in order to keep the curve. into pieces that can be fabricated out of flat pieces. You can see here the installment of the wood shuttering, and you can see in the end the finished wall. And obviously this would have been, in the precision that it is done here, not possible without the input of these engineers. This again being a project in Norway, and the project might be interesting or not, but what is interesting about this project is the front facade. The architect again had this vision to create a giant atrium entry space, and the surface that you see here I think is 30 meters tall. And again the question is, how would one start to think about a giant surface like this to construct? And again the conceptual approach was to, how can one break down a big surface like that in order to keep all the design intents of the architect, these folds, the holes, into flat pieces or curved pieces. But I think the important thing is to basically define the single elements, the component that constitutes again the overall organization. And again, digital fabrication was used to cut the elements, to cut the structural elements that will carry the facade. Again, organization of numbering, which place comes into which position. And here you can again see the humongous scale of these structural ribs on the bottom that start to be cladded with the vertical wood panels. And I put this project inside because we mentioned before that digital fabrication, being understood made out of wood, is something quite conventional. We used in our workshop paper, but I think Andre mentioned that a large number of other industrial design fields like car manufacturing start to intervene in architecture. And I put this project in the presentation because this is a project from Arata Isozaki, and the construction company has been a company from the Netherlands, which has been for I think 20 years only engaged with building ships. They didn't do anything else than building ships, and they are now specializing to work for architects, because what they are experts in is how they can bend steel. As we all know, the form of a ship, it has certain parts where we need to bend steel with precision, and architects are kind of borrowing this information from different fields to realize their own projects. This would be a single piece of bended steel loaded onto a truck, and you might like the project, you might not like the project, that's a subjective decision, but I think it is really interesting of how suddenly all new kinds of forms can be done with borrowed information from other fields of the industry. Or also artists. This is Anish Kapoor, an artist from London or from India, who uses the same company as the architect to realize his visions of sculptures. And this, I think, is interesting to show, because this shows, again, let's say, the economic part that digital fabrication and parametric architecture has. This, again, is, let's say, a building. But what is interesting is that through digital fabrication and design processes, we can navigate between panels of different forms, so flat panels, curved panels, and double curved panels. And we can approach a design in a different way to calibrate, let's say, the economic output of the building. Is it, how expensive it's going to be? And a large part of the professional company is actually going always through an optimization process for the architect to make their innovative designs viable on the market.
Bence mentioned before the similarities between the Shigeru Ban project, the golf course in South Korea, and the way how digital fabrication was applied into a large-scale building. and the way how you guys worked in the workshop. It is our understanding that if we, as architects, will have to introduce new digital design techniques to the clients, you as architecture students will have to know these tools. So you'll have to become proficient in using these tools. And we have been showing you until now some digital fabrication projects. Now we would like to focus on two fields of digital design architecture, one being algorithmic architecture and the second one being parametric architecture. And talking about algorithmic architecture, it's important to realize that it's not only using the computer in a way how you would use AutoCAD, just to draw what you think is in your head, not on paper, but in a computer. It's about more or less using the computer as a discussion counterpart. Having the computer being, having the possibility to use the computer as a kind of a feedback tool to explore new design opportunities. And part of this has to do, of course, with design efficiencies, because you all know that the computer is able to do things faster as us as humans, but this using the computer in a traditional way creates problems, because we are using softwares to communicate with the computer, and this problem of form follows software is actually very problematic today, because we all know that designing in SketchUp, you will probably end up with projects consisting of stacked boxes. If you design in Maya, it's very easy to create blobs, so the projects designed in Maya look somehow blobby and shapy. So every software has its particular things which can be done more easier than other things. So who has control over the design process? Is it you as a designer, or is it the software that you are using? And this is a very specific problem, and therefore algorithmic architecture tries to approach the problem by teaching you creativity through code writing. Some of you have been in the AA workshop in the last month, and the idea here is really that you, in the same way as you know how to use the pencil and the paper to draw the very basic sketch by hand, you would be able to use code writing as a very similar brick in order for you to develop your own software, in order for you to develop through this software your own design. So almost like creating and shaping your own tools, and not using tools that others created for you. Of course, this will imply some indirect design control, because there is not a linear process between a top-down idea that you have in your head and you know exactly how your building would look like, and you copy this in the computer. But in algorithmic architecture, you talk to the language of code writing. So there are some unexpected moments in there where the design process can improve from and can benefit from. This is a project I've done it 2 years ago with colleagues at GST Harvard, developing a high-rise building out of algorithmic techniques, and finding also contextual links to the desert setting it was set in, and developing shading modules and stacking them in order to derive a new typology. And I think this being another one, a church in this case, and I think I'm only showing this because a combination of this amount of modules would have not been possible by using traditional design techniques, and they nevertheless create something new beyond just a mass aggregation of them. It's all about creating different types of spatial experiences. Something linked in this field is also the idea of agent-based simulations, and how this again borrows knowledge from other fields. These are components derived from the military field, where simulations have been made for war games, and all of a sudden this intelligence, these systems can be used in architecture to simulate how people behave. For example, if you look at this example from Space Syntax, an office based in London, they are using exactly this systematic approach to simulate how people would move in a shopping center if through different layouts of spatial layouts, people tend to go rather in this shop, in that other shop, if they would rather go to the left, to the right, or to their left. So it's all about finding out knowledge through the kind of parameters that you set. And this being another example of how you might apply this into urban massing and creating different examples of densities and porosities.
I think another value of let's say code-written design or design that uses certain algorithms to arrange things is that I think at the very beginning there's always a surprise moment in this project, and this surprise moment has to be then translated into our own field, into architecture. We have to somehow make something with it. This is a project from a friend of mine that he did it for his thesis, and he was for a certain while obsessed with these sticks and how they can be arranged and what kind of patterns they can create. But at this stage, what we see here, he didn't really know what he wants to do with it. So he was, I think also another value is that you can really have an enormous output in a very short amount of time, and then actually it takes the conceptual ability again to make use of this surprise, and he decided to use this kind of woven structure as a facade for his thesis project, which was a library in Hungary, and then suddenly this kind of nested woven structure started to make sense, where he can control light, where he can control permeability, he can create connections between the inside and the outside space. It can become an environmental factor. We can see here, the different levels of the project and how the project is being wrapped by this nest. And in the end, it kind of looks like an architectural project, but it still resembles, I think, the kind of surprising design effect that he had very much in the beginning, where he actually didn't know what his scripting purpose was. Effects of the interior. This is a project that I have been working on in London, and again, if we look at this kind of organization here, it's just lines that are driven by an attractor, and it was kind of interesting to tweak the parameters to have different organizational outputs without having exactly an idea or a clue what we want to do with it. Slowly, these different typologies, some were more useless. We started to attach these curves maybe to the idea of circulation. The task was to design an expo fair pavilion that would float in the water. So at this stage, I think our main point of interest was to look at these curves maybe as paths through a museum. So for example, suddenly the amount of intersections where you could connect from one path to the other became interesting. As you can see in the bottom line, slowly we started to make an approach from the algorithmic output into a 3D model. So, at that stage, there was a literal translation. Okay, maybe these curves is actually a path where you walk and you have some exhibition on the left and right. Maybe you can make cross connections at the points. We started to model this in 3D, put them in the water, evaluate how they look like. And then in the end, you kind of crystallize or finalize your outcome. And this is again the complete translation from the abstract, almost diagrammatic output of the algorithm into an architectural floor plan that has, it has levels, it has ramps that have to work, it has program embedded in it. But still, the connection to the kind of surprising moment at the beginning is quite important, and also I think inherent and readable still from the architectural output of these plans. Here some further diagrams, and here in this architectural diagram, you can relate the idea of circulation that at a certain point started to drive the experiments in the beginning. This being the, let's say, the architectural imagination of how this project could look in a built way.
And the second field that we, would like to discuss with you is parametric architecture. And we think there is a slight, but nevertheless an important difference between algorithmic and parametric architecture. In parametric architecture, you are not only drawing by inserting objects, lines, points, and so on, but you're drawing or you're designing by setting up relationship between these projects and between these elements. And on one hand, of course, this approach facilitates the possibility of creating multiple design iterations, because by having these parameters set up between these elements and changing these parameters, with the power of the computer involved, you can create a lot of different scenarios. And you can, we think what is really important is how you evaluate these different scenarios. How do you define that they are more or less interesting or more or less important or relevant for the design process? In any case, they are, through parametric architecture, you can have an immediate design feedback. Whenever you change or you adjust your design parameters, you can have it in real time evaluated by the computer, and then you will have to reincorporate it into your design process. So it's a much faster process in terms of workflow. You are much more flexible in design explorations because, of course, the computer is doing a lot of work for you. And what is really important with incorporating other plugins of softwares, for example, is how do you evaluate this range, this huge amount of possible iterations of a design project? And here we think that, or we see that structural, environmental, functional analysis becomes really important to become one-to-one incorporated into the design process, and you can rely much more on data from consultancy companies, for example, because you share the same 3D model and they re-evaluate your design iterations and are able to give you a direct design feedback. Also, what is interesting is that it's very difficult for you to expect what the outcome will be, as opposed to a top-down, idea-driven traditional design process where you know exactly how your building should look like and you simply draw it. Parametric architecture allows you to explore different possibilities which were at least not expected before entering the process. This is a project I've been doing, and I'm showing this because in this case I linked the functional capabilities of the space, this being a basic cell within that building, which was created for the United States Air Force Academy in the USA, Colorado Springs, and I linked different spatial characteristics, what the space would be, to different parameters, depth, width, height, light conditions, and so on, and created different modules which then were arranged in a certain structure following, again, circulation intelligence, for example, in this case, and then creating a building which at some point started to integrate with the landscape, with the surrounding landscape. So there is one overall strategy, and through this parametric approach you could let the building become part of the landscape, or the landscape being integrated through the building itself. And yeah, these are some images. This is again one video showing how this manipulation of different building parameters can work on a smaller scale. In this case, a part of the facade component in a high-rise building in Moscow. And what is really important for us to state is that Parametric architecture is not something new. It's also not something which can only be done with the computer. People like Gaudi used the idea of parametrics in their buildings, and these are examples from Sagrada Familia, actually from an analysis of Sagrada Familia in Barcelona, where you can see how Gaudi, by tweaking different width, skewed, height of his architectural elements, he created very differentiated modules actually out of the same base. And you can see all the shapes being present throughout the project, but slightly changed. And someone else using parametric knowledge without using computer was, of course, Fly Otto with his minimal line systems, where minimal lines networks were used and tested in order to improve, circulation or structural needs.
Maybe again just two examples that I've been working on that deal with parametric architecture. One being two projects on a completely different scale, but still with a very commonly shared conceptual approach. This would be without a function, a kind of experiment in Grasshopper, where we could populate a minimal surface. This again being the same component. Change within its attributes, and then brought into a certain form of organization and array. Again, this being parametric because, as we can see here, the different components can be just easily tweaked in their arrangement, as we all know from Grasshopper, just by numeric values. And obviously also this could be one shape, but this could be also, of course, the same component could be brought into a completely different aggregation and could become, instead of being a linear element, into something that is more a surface-like element. For me personally, this was the test to see how a kind of funny, weird component could create at the same time something that is being like a column versus something that is being something like a surface. On the other hand, just going quickly again through a project from the office where certain aspects of parametric approach were used on an urban scale to create a new city center in Sofia in Bulgaria. On the left hand, we would see the old city center, and the brief of the competition was to develop a complete new city center on the second periphery ring on the city, which we would see on the right hand side, and again network connections. And the idea of the architect was to find parametric ways to create different building typologies and to condense all the buildings into a square form in the middle of the square. I think the interesting idea is not the organization of the square, because that's kind of almost like an ideological approach, but that certain building parameters like square meters, the function of the building, the amount of openings the building needs, building heights, regulations that come from one side, the brief of the competition, on the other hand, from urban regulations that the competition has to fulfill, we were able to create, through certain parametric approach, different building typologies that then in the end would constitute floor plans and an overall organization of let's say, something that could be a new city center. This again just the vision of the architect, how these spaces could look like. And I think we're coming slowly to the end of the lecture, and I think we've covered a lot of different case examples from the current field that are being used in academics, but also being used in the profession. And I think it is important to give our idea where all this accumulation of this knowledge might go in the future. And again, as said, softwares that derive from how we build airplanes are being used today on how we deal with architecture. This being a project from Daniel Liebeskind, where the digital design, the output of the architecture goes straight into production. This again on the left hand being a component that fits into a larger aggregation of the overall form, and in the end constitutes the finished building. The same case example with a high-rise, transfer slabs being modeled with individual bolts. We can see here how details are being developed through the computer and then immediately go into production from that stage. And I think that the future of a possible scenario of the way we're going to work maybe in 20 years is that paper will be abolished, and the contractual document between an architect and the contractor, which today is stacks of plans and packages, will be a final 3D model. And we will no longer draw sections or plans or elevations, but the contractual document, and there are case examples of projects like this by Franco Gehry, where the document between the architect and all the other related parties will be a finished 3D model. And this model is going to contain everything from structure to ventilation to electricity to details, through cladding, through facade, through openings. It will contain everything, and this will be the kind of like model between architects and the rest of the consultants.
And the second point where we think this is really crucial for the why digital design and fabrication is really crucial for the future is the question is how to involve students and how to teach students. We are involved in academia, and you as our students will be the future architects. In some years, and you'll have to be accustomed with what we saw today in a way that you also approach it critically, not only just do whatever is fastest or easiest in a certain software, but to develop a critical approach to the capabilities of the digital design opportunities. And this is the reason why we think that there has to be a shift in education. We think that it's much more important than in earlier times to teach students through one-to-one, full-scale model, workshop style events that we did with you guys, because in this way you can really start to learn about not only the virtual capabilities of the software, but also how to build it in full scale. And we think this is really important, and this is why I think you should be really happy to have interested staff and really people pushing you in this direction, because it will not be only about knowing Grasshopper in future. It will be about knowing how Grasshopper and how this knowledge in digital design can be applied and used with digital fabrication tools in real architectural projects. And this is a project, I'm showing it to you really briefly. In the United States, I've been doing with students in a longer workshop. The task was to develop a structure for a lobby space in Portland, Oregon. We started from using minimal line system and some system assist, and incorporated in this case also functions, how you would incorporate furniture, shelves and places for showing posters and displaying posters, and again using and knowing the tools for design, Grasshopper, but also knowing the consequences of what you are doing in a real architectural way, in a functional way, is really important. The idea was also that there should be incorporations of sensors and how it's possible to let this structure become interactive with people moving. And then the process of construction. How, as you all know, as you all saw in the last 2 days, how can you derive and develop a module which is actually buildable, and how do you go through different iterations of modules, of structures, of connections, of joints. How do you connect them, how do you separate them to insert other layers, to integrate other systems. For example, transparencies. How is it possible to combine two materials and manipulate, in this case by thermoforming materials in order to create spatial effects. How can you use parametric softwares in order to create a non-standard piece which consists of 200 different modules, and you model this module just once and then you apply it to a surface, and then it gets automatically adjusted in a bit of a second. And then how you send this file to the laser cutter in order to cut this out of plywood. And as you saw, it's really important to know the limits of the software, the limits of the machine. How thick can you cut? How much time does it take? How much time do you need? With what type of material? Again, here we tested, different design options of taking local flora and incorporating it into the structure to make, to take account of the local context. Joints, really important. And then something really important for full-scale digital fabrication projects: the logistics. You have to know, you have to understand, you have to be proficient in how much time does it take to combine all these pieces. How do you make sure that the logistics work in a very different way as they would work in a conventional project? Because here you are dealing with thousands of pieces which are very similar, and you will have to find a code in order to know at what place they would fit, when do you deliver what. And of course, this being a small-scale project done by students, but you will show in the next project how this can be translated onto a bigger scale, in an architectural one. The problem of transportation, mock-up creation, details. Yeah, and we would like to finish with the project we have done in Vienna, where actually all of the things we discussed and encompassed today, somehow feed into a project on a larger scale. We've done 2 years ago, from 2008 to 2009, in Vienna. It is for the Academy of Fine Arts in Vienna. And the Academy of Fine Arts uses these large spaces, which was built 200 years ago, for student work, student space, studio space. And their problem was that these spaces, which you can see in here, were very difficult to use for lectures, for smaller seminars, because they are just huge sheds, huge halls, built 150 years ago. And they needed smaller spaces within the larger space to have smaller groups of students and give lectures and seminars and so on. And the idea was to incorporate smaller pods, lecture pods, but also to incorporate functions. In this case, to incorporate furniture into the outside walls, storage space, to have an acoustic separation, and we created, I think there were 8,000 different unique pieces cut by CNC machines, similar to the machine that you have in your spaces. And the problem was, how do you deal with the construction process? How do you develop the logistics to have all these 8,000 different pieces arrive at the right place, at the right time, and to be assembled by humans, with the human error involved. We had to write the code on each piece and make sure that they are, they are in place. Here again, the idea of incorporating functions, computer working places, interior spaces with a screen to the outside, which is able to be enclosed for presentations where you project. The difference between inside and outside was very important for us, to have very neat, clean, white box spaces in the interior to play against the card of the interesting ancient architecture. This being the cast iron column built 150 years ago in a totally new abstract environment. And the idea of using the texture of the old wooden floors to grow it into the wall and let it become a new language with the same architectural grammar as before. And also the idea of not only using these elements as ornament, but this is actually also the structure. So these cut wood pieces are assembled and are a self-supporting structure, which are ornamentation at the same time. So again, the idea of integrating different systems and different ideas into one architectural piece. Yeah, you see the furniture and different elements and how they react to each other. Opening and closing of spaces, transparencies. Yeah, and that's it for the lecture. We want to thank you very much for.
And we're very happy to answer any questions. Hopefully, there are some that you guys might have. Or not. Okay.
Well, thank you very much for the workshop. Thank you very much for the attendance.